Right, thank you. Thanks, Tony. My talk is about running Julia on a Raspberry Pi. Now, the Raspberry Pi is essentially a $35 computer. It looks something like this. If I can get it through the wires, that's what it looks like. This is a camera module attached to it. Let me just get that. And so it just looks like a raw circuit board. You attach a keyboard and a mouse, and you attach an HDMI adapter, connect it to a TV or a monitor, and off you go. And it's all in this credit card sized box that you can buy for $35 anywhere in the world. It was created by an educational foundation called the Raspberry Pi Foundation, which was founded by a guy called Eben Upton, sorry, not the other Eben. He started it about 3-4 years ago. He used to work for Broadcom, and he used a set of Broadcom chips to design this computer at a very low cost. They have sold about 8 million of them at this point, I think. And so right now it is known as the highest selling computer product out of the UK, for example. So it's been very popular, of course, and it's gone through various revisions. The current revision is called Raspberry Pi 3, which is faster and better than before. So the current specs for the Raspberry Pi 3, which is what I have here, is it's a 4-core ARM CPU. The CPU is itself 64 bits, but typically we run 32-bit OSs on it most commonly. It has only about a gig of RAM, so that's where you suffer. It has a very powerful GPU. It's got a Broadcom Video Core GPU, and that can basically give you 1080p at native speed. So if you want to watch a movie on this, you can, even though it's a very tiny little thing, because of its powerful GPU. You can watch MP4 decoded movies at native speeds. Right? It also has a lot of externals. So it has Bluetooth, Wi-Fi, 4 USB ports, an Ethernet port, so you can connect it out to the world. For our purposes, also interestingly, it has a set of 40 GPIO ports, and we'll talk a little bit more about that in detail. And that allows you to connect to the external world, connect to external hardware very easily. Right? So that's the specs. The original version had 512 MB. Actually, the first one had 256 MB. The second version had 512 MB. Raspberry Pi 3 has 1 GB of RAM, and that's usually enough to run Julia quite comfortably, as we will see. Right? This thing runs Linux, any ARM distribution of Linux. The most common distribution is called Raspbian, which is created by the Raspberry Pi Foundation. It's really a Debian/Ubuntu clone, it's a very standard Linux distribution. Nothing very exotic about it. There are other distributions. You can get sort of a pure Ubuntu for it. You can get Arch installed on it. Depending on what you are comfortable with. Raspbian is the easiest to get started with because the images are all the drivers are there. Just download an image and you're good to go. It's meant for educational use, so it's full of compilers that people can use to learn technology. So it has the C, C++ compilers, Ruby, Python, and Mathematica are installed by default on Raspbian. The other interesting thing that we will see a little more later is it also has Minecraft installed, a special version of Minecraft called the Minecraft Pi Edition, which has some special magic that we will talk about later. And we hope that very soon we will have Julia included in the base image as well. We've been talking to the Raspberry Pi Foundation, and they're waiting for a proper binary installation that we'll create. Hopefully 0.5 will have the ability to be on the Raspbian installation by default. So that'll be great. Right. So GPIO. So one of the key features of a computer that looks like a circuit board is this idea of general purpose I/O pins. And they are basically a set of 40 pins that are on the edge of this board that basically allows you to control through software electrical signals. Really, that's what it is, right? You write a code to control the electrical signals on each of these pins, right? So these pins that I said, there are 40 pins. They all have, they are, each of these 40 pins have, a purpose and a name. So the top two on the red, for example, you see provide a 5 volt power to anything that you connect to it. And the sort of yellow on the bottom left provides a 3.3 volt connection power to anything that you connect to it. The other ones which are numbered are software controllable. So they usually provide a 3.3 volt power, but that you can control through software. So you can set that pin to high or low, and that will set voltage to on or off, really. So a general purpose pin, as I said, can be set to input or output, depending on whether you are actually providing power or measuring power that's connected to it. It can be high or low. High is actually 3.3 volts, not 5. That's a mistake, sorry. So high is 3.3 volts, low is 0, and that, as I said, you can control through software. So you will create a circuit like that. If you see the picture, you have a diode that's connected to one of the pins through a resistor connected back to another pin. Now the second pin that you connect to probably makes sense to have a look at here. The things which are marked black on this are ground, so that's 0. So when you create a circuit, you start from something that gives 3.3, and then you connect it back to a ground to complete your circuit. So that's what this circuit is. If you see, the LED is connected from a 3.3 volt through a resistor and back to a ground, right? So that's the kind of circuit that you would create, and then you would control the pin, the positive pin, as 0 or as high or low, and that would basically get you to blink the LED, for example, right? So that's digital 0, 1, high, low, controlling power through to a pin. But some things need variable power. So for example, when you're controlling loudness or brightness, if you want to control the brightness of an LED, or you want to control the color of an RGB LED, for example, you need variable voltage. 0 or 1 is not good enough. So what do you do for that? One option is to have the controlling circuit in the thing that you connect to, and then you sort of digitally address a floating point value, for example. But that's for more complicated circuits. If you just want to connect an LED and you want to control its brightness, there is this concept called pulse wave modulation, or PWM. It's actually very neat. If you think about it, it's obvious, which is that you have a pin that goes high and low. If you pulse it up and down, average it over time, that's the power that you supply to that circuit, right? So you take a pin that, as I said, supplies 3.3 volts. When you set it to high, you keep it to high for 10 milliseconds, and you keep it to low for 10 milliseconds, again back to high for 10 milliseconds. You actually are then supplying 50% of the power that a constant voltage would give you. So that's how you control. You sort of provide analog outputs from a digital output that a pin normally provides. So that's called PWM, and that's how you do more interesting things. Now let's sort of keep that in mind while we move on to talk a little bit about Julia on the Raspberry Pi, and we'll come back to PWM and LEDs a little later when we see the demo. The Julia on the Raspberry Pi, 0.4 sort of works, but 0.5 works well. And I say here not x86, which means that it's a completely new chipset and processor, and so it's a big deal, right? Porting a compiler to a completely new CPU, And so I think it's important to acknowledge that it's a huge deal that we now have Julia working on the ARM and also on the power. And in a language that's this young, it's, I think, a very big deal that it works so well. So on 0.5, it works reasonably well. Most things work. The entire C ABI has been fixed, so that works. You can call into, you can do C calls into C libraries quite easily. Compilation speed is still a problem. Building Julia takes a long time, but even after building Julia, once you start it, just compiling the first function takes a while. But once a function is compiled, then it's pretty snappy. And I would say that compared to my Mac, on a single core on a Mac versus a single core on the Raspberry Pi, most operations are probably 2 to 3 times slower, but compiling Julia code is probably 10 times slower. So it'll hurt a little to once you let's say to include a new file or do the first using, but once you've done that, it's pretty good. The one thing that still doesn't work is stack traces, which Jameson will fix very soon, I hope. But that's, as Stefan said earlier, the weird mix of static and dynamic that Julia is, doing these things are very difficult. Right. So what can you do with Julia on the Pi, apart from just running any other code? So there's a package that I've been working on recently called pygpio.jl, which you can clone. And that basically allows you to control these GPI opens, do PWMs from Julia code. And we will see some demos. And it connects, the way this pygpio code base works is that there's a pygpio daemon that listens on a network socket. And what that means is you could potentially control a Raspberry Pi from another device. So you can control it from my Mac to the Pi, and that's useful in some circumstances. Right, so that's there and available to use. The other interesting thing, as I said, about the Pi is that it includes Minecraft as a default install. Minecraft is arguably the world's most popular game at this point, and it's owned by Microsoft right now for many billions of dollars. It's if any of you have kids in the sort of 6 to 12 age bracket, you would have heard and used Minecraft. It's amazingly popular, and sometimes you'll wonder why it is, but it is, and kids love it. It allows them to build stuff, right? And that's something that it's amazingly good to do. So Raspberry Pi includes a free edition of Minecraft. That's in the default image. It only includes what is called creative mode in Minecraft. So Minecraft comes in 2 modes: creative, where you just build stuff, and then there is sort of the proper game mode or competitive mode, where you have to stay alive and there are things that attack you and you have to feed yourself and all that. In the creative mode, none of that is there. You just it's a world, it's an open space. You just build stuff. You have components like wood and grass and lava and fire and all that, and they follow simple rules of physics, and you build stuff with that, right? And that's that's useful and that's nice. But what Raspberry Pi what Minecraft on the Raspberry Pi does is that it gives you an API to control it from code, right? And by default, it's in Python, but now there is also a Julia API to do that. And the ability to have an open world where you can build stuff and then write code to build stuff rather than building with a keyboard and a mouse is again amazingly powerful. And you can build some really cool educational stuff, or just to teach programming. It's much more fun to teach programming in Minecraft than to teach programming, printing arrays, for example. So that's really the background of running Pi on the running Julia on the Pi. Let's now see something real rather than just talk about it. So I shall hopefully Right, let's see if this works. Yep, okay, perfect. Now, unfortunately, because this is the Pi connected to the screen directly, I will have to look behind while talking. So, pardon me if I turn my back to you. All right, let's see. I have another about 10 minutes, right? Yeah. Right. So, this is the Raspberry Pi. As you can see, it's a standard sort of Linux desktop. It has the browser, and Mathematica is up there, and you have a terminal, and I have Julia running here. So let's see if that works. Version info, and this is the first time I've run version info in that. As I said, compile times are painful, so you need to. It takes a while to compile anything for the first time, but the second time I run it, it will be fast, I promise you. It will be. So version info compiles a lot of stuff. The entire I/O system is being recompiled now. So anyway, so Julia, as you can see, works. The Julia 0.5, right there, and as promised, there. So once it's compiled, so I say, compilation is like 10 times slower than you're used to, but everything else is maybe twice as slow. So that's pretty good. So that's version info. So it's Julia 0.5. The system is Linux CRM, and the CPU is the ARM-v7 processor, and that's interesting, right? So the first thing that we want to do is use. Sorry, what am I doing? Using PyGPIO, right? And since this is 0.5, there'll be lots of deprecation warnings, so don't worry about that. Let's get rid of that, and then we create an instance of this object that gives us a reference to the device itself, right? Again, you'll see this is compiling the entire package right now, so it'll be a bit painful. Now, if you were doing this from a remote device, you could say Pi and then provide the IP address and the port, and it would then connect to that. But by default, you can see it connects to localhost port 8888, right? Now, I'm not sure if you can see this thing, right? Something, right? Let's see. Right. Yes. That was something fell. Yeah. Okay. That is because I just lost. I'm sorry now. This. We'll now need to wait for it to reboot. So I just lost power. I'm sorry. Right, now let's see while this boots if I can. Right. Just leave it there. Maybe if I turn this a little bit to the side. No, this isn't. This is still not. Yes, that might be a good idea. Yes. Right, sorry, let's get started. Programming. Okay, terminal. So we start the daemon and start Julia. Yeah. Right. So again, the first time it sort of loads up, it's compiling the REPL, and that's a bit annoying. But now we say PyJPIOD, GPIO. And this first using is again going to be a bit time consuming. I had done all this, but then we lost power. So yeah, okay, that wasn't too bad. So using PyGPIOD, that's fine. And then we say P equals pi right. Now, if you notice over here, I have connected the GPIO pins to these LEDs over here with a resistor in between. And my red LED is connected to sort of port to the pin 18, right? And that's how I build the circuit. So let's say so the way I'll do it is I'll say set mode P18 output, right? Okay. And then I say write P18 high. Yay. Right. And then I say there's more. We can get it to blink as well. And low, and that's there. And so if I go here, and run this blink thing here, so we say we'll see red pin is 18, and then we say and there it is. Right. So that gives you an idea of the kind of code that you write to control things, and then you connect this to an LED, to motor controllers. You can connect it to switches, and the world is then at your command, literally. Now, one of the other things that you can do is the other thing that I've connected here is a RGB LED. So it has 3 or 4 pins, one ground pin and then one pin each for RG and B, and then you can control them separately. So let's go there, and let's say and these are connected to pins 23, 24, and 25, right? So let's go here, and then we can say let's say set mode P red pin output, and then we say set PWM duty cycle P red pin, and let's say 100. Right, and then you see it's light red, and if I make it to say 255, you'll notice it became brighter, and if I say make it 25, it became much dimmer. So that's setting the PWM. The duty cycle is basically the ratio of the time that it keeps the signal on, and it cycles it at a certain frequency. You can see what the frequency is. You can say get PWM PWM range, get PWM range P red bin. Yeah, so that says 255. So it uses numbers 1 to 255 to control the portion of the time. And you can set this to 1 to 100 if you want. The default is 1 to 255. And then you can say get PWM frequency P red bin. That's it. And that's 800 hertz. So that's the speed at which it's going up and down. And I said if I do 100, then it'll do 100 by 255, and that portion of the time it'll be down, and the rest it'll be up at that frequency, right? So that's PWM control. Now I can, let's set this back to 255, which is 100%, and then let's do green pin, yeah, and that's green, and the green is pretty much, and then when I say red pin 0, and that's pure green, and I can add some blue to it. So let's say add blue pin, and let's say 50. Yeah, and that adds some blue to it. Add some more blue, and that's a lot more blue and green, right? So this is, you can control, you can provide sort of analog outputs to stuff. Now, what can you do with it? Julia has, a very good colors package, as I'm sure many of you know, and you can, use that to do stuff. So, for example, let's say I do this, right, using colors. And a lot of this is actually Tim Holey's work. Among other people, and you can say, for example, you can say DC equals, let me just cut paste, it will be quicker. So this gives you a set of distinguishable colors, which are, it gives you a set of 10 distinguishable colors, which are sort of well separated in the color space. And so those are the 10 colors that you give. And sorry?
The first line.
Ah, yes. Thanks. And then you can, you can loop through those colors and display them on the LED, and you can see there are sort of 10 different kinds of colors as far away on. So this is something that again it's good to use Julia for, right? It's difficult to do this in other languages. The actual control you can do it in Python and C, and it's similar, right? Now there is also I don't know, some of you may have seen there is a IPython notebook that Jiahao had made called The Colors of Chemistry in Julia, which is a great demonstration of using Julia to do a lot of cool stuff. So we can use it to for example, calculate the colors in black body radiation, and display those colors using so that's the Planck's formula to calculate the black body radiation, and then we take a set of 30 temperatures and calculate the colors of black body radiation for each of those temperatures, and that'll be available in this array called black bodies. And then we can now normally what you would do in a IPython notebook is to plot them, or iJulia notebook is to plot them, but here you don't have to plot them. You can actually see them, and it starts at red, which is sort of low temperature, and you will see it will start getting whiter. And you will notice that there is still a tinge. The color balance is not, the white balance is not great. So you can, I leave it as a exercise for you to figure out how to change the white balance of the LEDs, or buy a more expensive LED. This costs 20 cents, I think. Right. So that's LEDs. I think we have just a few minutes, which should be enough time to look at Minecraft for a few minutes. Right. So let's start Minecraft. Right. Start game. This is build a terrain. Let's see where we are. So this is basically the ground beneath our feet, and we can move around. So let's go near the water, right? And this is a world that's built by my son, so I don't know what's in there, but anyway, for our purposes, it's good enough. Right. So this is Minecraft. Let's get back to Julia. And as you can see, Minecraft doesn't actually go in the background, so it's a bit annoying if you have such a small screen. If you connect the Pi to a HD TV, you get, as I said, gorgeous 1080p, so you can have two windows side by side. On this screen, it's a bit annoying. Right. So you say using PyCraft. Right, and then basically you have commands like world, let's say chat dot post. Let's see if that works. Yeah. Oh, okay. Oh, sorry. Yep, and so you can post to chat, and then you can have command like world. So let's say player dot get tile, and that will give you the current position of the command of the player, right? So, and then you can have commands like world dot set tile, which will set the tile at that current position. Right. So let's, given that we are a bit strained for time, let's, I don't know what to do now. Okay. Okay, let's look at this code over here. SafeFeet.py. Let me just run through this. So this is a function called SafeFeet. And as you can see, what it does is it says xyz equals player.getTile, which is the current position. Then I say b is world.getBlock at x, y minus 1, z. Y minus 1 because I want the tile beneath my feet, so which is one below, which is so one step below my position. So that's where my feet is, and x and z are where I am. So that's the block that I'm standing on. Then I say if b equals air, which is if the tile beneath my feet is air, or if the tile beneath my feet is water, then I set a diamond block where I am standing. Right? So what does this let you do? Let's find out. Let's copy this here. Oh, this is annoying. Can I move this up? Okay, so let's copy that. Yeah, I think I'm out of time, but I'll just finish in a minute. Where's my mouse? Right. So paste that, and then I say while true, say feet. Yep, and now let's go back to Minecraft. Right. Go back to Minecraft, and I will start walking on water. So you see, I haven't sung. Normally, if I do there, I sing, and if I turn around, you will see that there is a bridge of diamonds where I walked through. Right, so that's superpower for you with Julia and Minecraft. Right, thank you.